Hello everyone, this is INE Foundation Lab 3 and section 6.4 VPNv4. Okay, let me explain VPNv4 and some BGP concept, and I will come back and conclude this section. Okay, let's start with VPNv4 concept. In MPLS world, we have route distinguisher. The idea is used to create 96-bit address called the VPNv4 address. In other words, VPNv4 address consists of RD plus IPv4 IP address. An RD is a unique 64 number that is appended to the IP address, thus making it a 96-bit VPNv4 address. In other words, VPNv4 address consists of 64-bit route distinguisher plus 32-bit IPv4 IP address. This is its form, VPNv4 IP address. VPNv4 address format. It consists of RD colon IPv4 address. This is VPNv4 address example. This 100 colon 1 is our route distinguisher, and this is our IPv4 IP address, 192.168.1.1. The format used to configure RD is like ASN colon NN, like this one, 100 colon 1. RD allows PE and LR routers to determine to which customer or particular prefix is belong. And RD must be unique for different VIF on the same PR or LR routers. Provide the edge, or it's called LR either. And we can configure route distinguisher on the RPVIF, old format or new format. We have definition name. On the RVIF, we can assign or configure our route distinguisher by the command. It is configured by the command and assign ASN colon NN, like 100 colon 1. Another feature in MPLS world is RT, or route target. The RT is a 64-bit or 8-byte BGP community, it is extended community, used to tag prefixes. It is used to control the distribution of VPN routing information between PE or LR routers, provided edge routers. And it is used to control which VPN routes are imported or exported between VRF. We can use RT to control and to import and export our route between our VRFs. This is how we can control our VPN routes by RT command. And the RT acts as a tag for VPN routes, and it is attached to the BGP update messages. And there are two types of route targets. One is import RT and the other one is export RT. Import RT is a PE or LR router imports VPN routes with an import RT that match the import RT specified in the VRF table. And export RT is a PE or LR router export VPN routes by attaching an export RT to them. In other for example, let's show this. For example, we can, if it is customer, we can let's start this. If it is C, this one is to C, we can use RT export here. And use RT export, RT import here. Export from here and import to this C router. And this is how we can configure route target. With the route target export, with the route target import, with the route target map name or route target import export map name or import map name. This is how we can export and import our root target. And with the root target command, this root target command, the root target is added for all VPN routes. And with the import map or export map, we can filter VPN routes. There is two ways we can use. We can import and export root target by either root dash target command or by export and import map. Okay, we can see this in the next section. I will explain this in the next section more. Another concept for this section is this BGP Route Reflector. We need to understand what BGP Route Reflector is. Okay, to understand BGP Route Reflector, first we need to understand some BGP rules. The first BGP rule is the BGP Synchronization Rule. What is BGP Synchronization Rule? Okay, the BGP Synchronization Rule is a principle in BGP used to networks where both BGP and Inter-Gateway Protocol IGPs like OSPF or ERGRPs, like OSPF or ERGRP operate together. It is used in network where when we have both IGPs, for example EGP, ERGRP, RIP, and so on, and these are called integrated, and BGP, BGP. This rule ensures that BGP does not advertise route to external peers. This is BGP synchronization rule. This ensure that BGP does not advertise the route to external peers, for example another iBGP, unless that route is known to and synchronized with the IGP within the autonomous system. Okay, in other words, if synchronization is enabled, a BGP router will advertise a route to an external BGP neighbor. Will advertise only if that route is present in the IGP routing table and is synchronized across the ASs. If synchronization is on, then BGP only will advertise only if that route is present in the IGP table. For example, OSPF and ERGRP routing table. And if synchronization is disabled, BGP can advertise the route regardless of whether the IGP has learned that route or not. If synchronization is disabled, BGP does not care about that route if it is learned in IGPs. Okay, this is how BGP synchronization rule is working. It's used with if we have both IGP and BGP in our network. Another iBGP rule is BGP Split Horizon rule. It is also called iBGP rule. But in general, Split Horizon rule is for both eBGP and iBGP. Okay, let's see what is BGP Split Horizon rule. In BGP, the concept of Split Horizon refers to a practice that prevents a route running from one BGP from being advertised back to the same peer. This is like similar to Split Horizon rule in our IGPs. This behavior ensures stability and prevents potential routing loops in our BGP network. Okay, let's see behavior. This is okay. The split. Okay, this split horizon rule can be used for both eBGP and iBGP. In BGP for iBGP, in general BGP, this is eBGP. Rules learned from an external BGP are not admitted back to the same peer. This is like in other. This is like our IGP split horizon rules. And for internet BGP or iBGP, a route learned from one iBGP is not admitted to another iBGP unless certain conditions are met. For example, the presence of route reflector or condition. This is iBGP rule, same as iBGP rule, split horizon. The iBGP learned from will not admit to another iBGP rule. And the impact of split horizon is iBGP peers must be and for this reason, for this rule behavior, iBGP must be fully measured because of the split horizon rule. This is the split horizon behavior, and each iBGP rule must form a direct BGP session with every other iBGP routers in our AS to propagate routes. Okay, for this behavior, we can override this feature. We can overcome the split horizon in BGP either by route reflector, BGP configuration, or eBGP multi-hop. In this section, we need to understand route reflector. This is why we need route reflector for this rule. We use route reflector to propagate iBGP routes between clients, and this eliminates the need for full mesh iBGP topology. This is how route reflector is working. This is to eliminate the need for full mesh, because for this split horizon rule, iBGP must be fully meshed for the split horizon rule. And for overcome this, and to simplify our configuration, we can use BGP route reflector. Okay, let's see how BGP route reflector is working. The route reflector configuration is so easy, just we need to understand its rule. Let's see BGP route reflector. The route reflector can have three types of pairings. One is eBGP neighbor. This is neighbor to our route reflector. Okay, let me draw this picture. Okay, this is okay. This is our client in our route reflector inside cluster. We have route reflector, our client inside cluster, and this is client outside cluster. This is non-cluster either, and we have eBGP route here. This is our eBGP and eBGP. Okay, the route reflector can have three types of peerings. One is iBGP neighbor, the neighbor to our route reflector. This is our iBGP neighbor. This is neighbor. It is neighbor to our route reflector. And iBGP client neighbor, or neighbor between route reflector and client inside cluster. This is these three are iBGP client neighbor. And another type of peering is iBGP non-client, a neighbor between route reflector and client outside cluster. These are non-client. These two are non-client peerings. Non-client, iBGP peering, non-client, and client peerings in route reflector. These are three types of peerings. And let's see how route reflector rules work. It says route learned from iBGP neighbor can be forwarded to another iBGP neighbor, a client and non-client. Okay, if there are this another route learned from iBGP can be forwarded to client, can be forwarded to non-client and another iBGP. And route learned from client inside cluster can be forwarded to another iBGP neighbor, client and non-client. And route learned from client can be forwarded to another client neighbor, non-client, and iBGP neighbor. Okay, we can one thing to we can disable client to client reflection, but no BGP client to client reflection command if we want to disable this client to client reflection. If we want, there is this one. Okay. And third one, this is with the working. Would learn from non-client outside cluster can be forwarded to another iBGP and client, but not another non-client. This is the normal iBGP or Split Horizon rule. Route learned from non-client can be forwarded to clients iBGP, but not another non-client outside cluster. This is how it is not in BGP in iBGP rule. We don't have non-client to another non-client with reflection. This is not allowed. This is a normal iBGP rule. Non-clients can only forward to client outside inside cluster and iBGP. Okay, and for the configuration of route reflector, so easy. The the router that we want to become route reflector, we simply configure this on our route reflector routers. We configure neighbor, IP address, and route reflector clients. This is how we can configure route reflector. On route reflector, we have this configuration: neighbor, remote IP address, route reflector dash client. From this command, we can understand that this router router is a route reflector. Okay, for verification, we can show up BGP, and we have originator ID and cluster list. The originator ID is set by the route reflector, and when our BGP router receives a route with its own router ID or with its own originator ID, it will not accept that rule. It's for payment and loop prevention. Cluster list. And the cluster list is the router ID of the route reflector, and when route reflector sees its own cluster ID, it will drop the route. Okay, this is how route reflector working in BGP and how we can configure it. And last concept for configure this section is how we can configure BGP either by BGP Peer Group and Peer Templates. Okay, for configure Peer Group, Peer Group is need to be created by this command: neighbor, Peer Group name, and Peer Group. Then add our favorite parameter, neighbor Peer Group. Then we specify neighbor Peer Group name and remove areas and apply another parameter if we want, and apply our Peer Group to our neighbor by this command: neighbor IP address, Peer Group, and Peer Group name. Another way is Peer Group template. So session template needs to be created first by this command: template P session and P session name. This is our P session name, and we add P session parameters: remote AS, iBGP water hub, and update source. These are under session template. Then policy template needs to be created, and we can create policy template by this command: template policy p-policy and name, and add these parameters. Route reflector client route reflector client is under our policy p policy, not p session. Next up, save route map, wait, and send community. Then we inherit session and policy templates under route BGP neighbor IP address inherit P session. P session inherit is under our route BGP configuration, and P policy inherit is on the address family in MPBGP. Okay, now let's configure this section. Okay, let's draw what we can see here. This is the site topology. Okay. What should we can do here? Okay. Okay, configure BGP VPNv4 exchange. Configure BGP VPNv4 exchange between 3, 6, and 5. Okay, it's 3. Where is 3? 3, 6, and 5. Okay, we don't need switch 4. Switch 3 there. 3, 5, switch 3 there. Okay, let's show IP BGP summary. This is 6500.2525. Okay, this is dynamic. Dynamic. No, but this is 6500.2525. And this is 6500.2525. This is our we have neighbor with 3. We have neighbor with 7. Our T's we have with 6. And this is our dynamic DMVPN. Okay, now we have to use BGP address BGP VPNv4 address family under these routers. Okay, we can count the BGP action between this one and conquer R8 as the VPNv4 route reflector for these PE routers in AS 6500.2525 and ensure that VPNv4 is the only active address family on R8. Okay, what does this say? It means that on R8, let's show the R8 SHA-P protocols. We only have ERGRP. There is no BGP. Show MPLS interfaces, and there is no MPLS enabled on R8. No MPLS and no BGP. Okay, ensure that VPN4 is only the active. Okay, we can achieve this goal. What does it say? It is MBGP. We have to configure this like this one here. Show ROM pipe section. Rotate BGP. We should add this command on R8. No BGP default IP for unicast. This command will make sure that only active address families are working on R8. We need to add this command. This will make iBGP MPBGP and add our VPNv4 address family on R8. Okay, let's start with R3. Okay, let's draw scenario. What can we can here? New. Okay, R8 is our route reflector, and it is AS BGP AS 6500 6500 6500 dot 2525 and 3 6 and 5 basically 3 6 and 5 are with reflector clients. Those are in 6500.2525 either. This is how we can conquer this. Okay, let's start by R3. Is R3. Okay, this is my BGP configuration on R3 in previous labs. I have with the BGP. I just need to add. I have no BGP. Okay, let's go to. I have here neighbor Peer Group. Peer Group name. Okay, let's go to the BGP config T. Okay, show IP BGP. Okay, show IP interface brief, loopback, okay, neighbor, emitter should be this one. This is the limit number 6 on R8. And because I am using loopback of R8 to form neighborship, then I have to use update command to tell this BGP that I am using loopback as a source, as an update source. Neighbor update that source and use loopback 0. Do show on file section rotate BGP. Okay, I have created my neighbor and update source. Then I have to create address family. Address family IPv4. Excuse address family. This is VPNv4 address family. Address family VPNv4. And unicast. Then I have to activate my neighbor. Activate command. Okay, do show down file section rotate BGP. Go upgrade address family VPNv4 and activate. Okay, our route 8 is our route reflector and T is our route reflector client. This is our route reflector client. Let's start another route reflector client. Let's configure 5 showdown 5 section route BGP. Okay, config T. This is another route reflector client. This is the same configuration. R5, R3. And address family VPNv4 unicast. Activate. It's the same on R6. showdown pipe section rotate BGP config T address family VPNv4 unicast and activate. Okay, now I have to configure Route Reflector itself on our 8. Okay, for simplify our configuration, I can use either Peer Group or Peer Template. Let me use Peer Template, which is newer one. I will use Peer Template instead of Peer Group. On our T, I have used a Peer Group already. This is our I've created Peer Group neighbor and Peer Group name. Then I have added object source and add my neighbor to Peer Group. Okay, I've created Peer Group name, and this I call my Peer Group iBGP. Then I have added parameter remote areas and object source is tunnel, this is our DMVPN tunnel. Then I have used a BGP dynamic neighbor with this command BGP listen range and added all of this network in this range to this Peer Group and Peer Group name iBGP. This is how I have used Peer Group and dynamic BGP neighbors together in previous lab. Okay, I will use Peer Template on R8. Okay, config T. It should be rotate BGP this one, and I have to use this command no BGP default unicast to make sure only active address families, only this VPNv4 address family is activated. Okay, let's create session template, session template session and session template name. For template, I can create two peers. One is session peer and policy peer. Peer session and peer policy. Peer session is to create a first template peer session. I specify name. Let me call it. Let call it VPNv4. Then I have to specify remote AS. That means parameters. These are all my parameters. Remote AS should be this one. Then, because I am using loopback, I have to specify update source. Update source is on the P session either. Update source loopback 0. Okay, that's it. Then I have to create policy template p policy and type it VPNv4. Okay, for policy I have to specify community, same community, and route reflector clients. As I said before, to configure router as route reflector, I have to configure this command. Here, because I'm using template, I simply select route reflector. Let's see. So I have to specify send community, port, and route reflector client command here. Container as a route reflector client. This command will make router 8 as route reflector client. That's it. Then I have to inherit both session and policy template. Let's see. Okay, session template can be inherited on the router BGP, and policy template can be inherited on the address family. Okay, let's go to what. Let's do showdown 5 section. Router BGP. This is router BGP. Okay, I have to add for this command either BGP AS dot to change this water. Okay, let me add water BGP and add this command either BGP AS notation dot. Okay, do showdown 5 section water BGP. Now it's correct. Okay, on the router BGP, then I have to inherit okay, neighbor IP address and inherit. Okay. I have excuse me. I have 3 neighbors, 3 I have 60 and 5 neighbor 3 and init p session and name is VPNv4. Same for neighbor 555 init and neighbor, the other one is 66. Then init VPNv4. Then on the address family, let's see my user run pipe section rotate BGP. I don't have address. On the address family, VPNv4 unicast. I have to init and activate my neighbors. Neighbor init I have only P policy and it is name VPNv4. Okay, I have to activate first. Activate neighbor. Five activate and neighbor 3516666 activate either. Then neighbor 3333 inherit P policy and neighbor 555 and 5 inherit and neighbor 666 and 6 inherit. Okay, now let's verify our route reflector 198. Show BGP VPNv4 unicast all summary. Okay, done. I have the third configured and working on R8. This is and show BGP VPNv4 unicast all. This is our route. And well, if I'm mixed up. Okay, that's it. But let's review what we have learned. We have refreshed our root target, what is root distinguisher, what is root target, and what is the job in MPLS and BGP. If I see here, this is my root distinguisher, RD. And show VIF. There is no way of receiving this distinction. Keep in mind, R8 is not configured as MPLS. Show MPLS. We don't have MPLS configured on R8. MPLS interface. There is no MPLS configured on R8. Okay. And then we see what are our BGP rules. We have synchronization rule, split horizon rule. This in general, we have a split horizon both for BGP, eBGP, and iBGP. Must be full meshed. This is simple iBGP rule. We have to configure full mesh, and for simple overcome this rule, we can use route reflector or route configuration or multi-hop. Then we have route reflector rules, 3 type of peerings, and how route reflector rule is working. We don't have only non-client to non-client reflection. No non-client to non-client reflection. And we can overcome this rule by this command. Either ways. We can disable client reflection by no BGP client to client reflection command. And so on. Let's see. Show IP BGP. Okay. It's not advertised. Okay, that's it. I hope you have enjoyed this video. Okay, well, I have one or two. We have configured P template. We can simplify our configuration by either by P group or P template. In this section, I have configured P template instead of P group. Simply, I have created. Let's show. Yeah. Show on pipe section. What a BGP. First P session is created by this command template P session. Then I have added these parameters on the P session. Then I have created policy P policy and added these parameters. Then P session can be initiated on the router configuration. Under this router configuration, P session can be init under this router configuration by this command. Neighbors in a P session, and P policy can be initiated on the address family by this command. First, I have to activate and init my P policy. Okay, I hope you have enjoyed this video and thank you for watching.